general strategies for integrating. And there were 4. So the first one was to simplify, if possible. Second was to look for an obvious substitution. Okay. Look for an obvious substitution. And then third, classify the integral. And fourth was to try again. So I wanted to do some examples where we were trying to integrate some random integrals, because on your test, I'm not going to tell you which technique to use. So you need to know which one will work and how to go about that, and the more you practice, the easier it's going to get, okay? So, write too low on this thing. There we go. All right, so let's start with our first example of this. Let's say I want you to integrate 1 over x, the square root, ln of x, dx. Okay, so let's refer to our general strategies as we go about doing this. The first one is to simplify. There's really nothing there for me to simplify, right? Can't distribute, can't combine some things. So next step, look for an obvious substitution. If you did substitution here, what would you let u be? Natural log of x. Okay, what's the derivative of that? 1 over x. Hey, in my integral, I have a 1 over x. So that tells me, okay, substitution is going to work here. Okay, so that would be the obvious substitution this time. U equals ln of x, du is 1 over x dx. And now we just plug into our integral, our substitution. So you're going to get the integral 1 over the square root of u du. Can you integrate that? Might help if you rewrite it.
Isn't that the 1/2 power?
Yeah, do the negative 1/2 power. And now do your reverse power rule where you add 1 to the power.
Is 2 u to 1/2?
Uh-huh. So I get u to the 1/2 divided by 1/2 plus c. So when you divide by a fraction, you flip it, right? So I'm going to get, let me move that up more. I'm going to get 2, and then I'm going to replace u by ln x, square root ln x plus c. Okay? And again, that's my answer. Any questions on how we went about that? We're okay? Sometimes the obvious substitution is really just staring you in your face. You just have to say, if I let u be this, does everything work out? Okay, yeah.
You're flipping it and just flipping one of them, or?
You're just flipping the denominator when you bring it up. Yeah. Other questions? Okay, so the one thing I haven't gone into extreme detail with on every example we've seen, I tell you that you can check your answer, right? So let me show that here. On an exam, if you had time, it would be a good idea for you to check that you actually integrated this correctly. All right, so let's take Let me make some room here so we can check this guy out. So I'm going to call my answer a function. I'm going to call it f of x. And you need to take the derivative of this. It might help you if you rewrite the square root as the 1/2 power. Okay? So now tell me what the derivative of this guy is, this function.
1 over x times square root of ln x.
So you get 1/2, right? Let's just do the chain rule. And then the derivative of the inside, derivative of ln of x is 1 over x. And the derivative of a constant is 0, so we don't have to worry about that. And then you simplify this, and you should get exactly what you told me. So the 2's will cancel. I get 1 over x square root ln x, okay? Which is exactly what I had in my integral to begin with, okay? So if you're ever feeling uncertain about if your answer is correct or not, you can try to check it by taking the derivative and seeing if it matches up. Sometimes it's a little bit harder to verify that this matches up with your original integral, okay? But if you have time, you should try, okay?